So let's look at a couple graphs that have been shifted, look at their domain and range. So the first one is the square root of x plus 2. So if we go all the way back to the first unit that we covered, we know that this shift is a shift to the left by 2 units. So if I were to do a quick sketch of this, the graph of it would look something like that. So if you're being asked for the domain and range of this, the domain, or all the x values, is the leftmost x value that we ever hit is -2. The rightmost, well, it keeps going to the right to infinity. As far as the range or the y values, the lowest y value we have is 0. And this guy keeps going up. Now the domain we could have actually solved algebraically as well, because we know that what we're taking the square root of, the x plus 2, we know that it needs to be greater than or equal to 0. So if we solve that for x, we find x needs to be greater than or equal to -2. Let's take a look at the second example. Square root of x and then plus 2. If we go back to our shifts, this is a shift up by 2 units. So if we do a quick sketch of this, it's a square root that starts there. So as far as the domain or all the allowable x values, the leftmost x value that we see is 0, and it continues going to the right. But as far as the y values are concerned, the smallest y value that we have is a y value of 2. But it does keep increasing after that. Now, as far as cubed roots, remember that every cubed root, your domain is everything, your range is everything. I don't care about the shifts. Now, yes, I could do the shifts on this one, and if I were to do a rough sketch, this would be to the left by 2 and up by 5. So that's my middle point, meaning I go upright and down left from there. So that's roughly what this guy would look like if I was graphing him, and I could get the actual ordered pairs using 1, 8, 27. But most importantly is this rough idea, and then there's your domain and range.